Thank you very much. Thank you for having us this afternoon. We have got a tight little timeline, boys. So as your chief cheerleader for this afternoon, we are going to cut the crap and we're going to get right to what you want from this room full of people here. So we've got 23 or 21, I believe, founders that are sharing their tech with you today. And in this session, I get to play cheerleader for these two legends here. And I really urge you to listen to what these guys have got to say. And I really want you to throw out your preconceived notions on the industries that they're working in. I think you will see very quickly that the scale of the challenges and problems that they are aiming to tackle is enormous. And you will see how what they're doing is going to make some really massive global impacts. So I want to get you all to welcome Julius Lewis from Cool Engineering and Dr. Peter Richardson from Facet Amtech, because we are going to talk about the fact that too often people assume that with enough investment and tweaks that any solution can succeed. But as we know with the laws of chemistry and physics, that you can't always navigate what that does, but they always have the final say. So I want to talk through the approaches that you've got today, your key challenges, and then how you're actually showing us how we're going to have some impact there. So we're going to be talking about your technologies that are not incremental tweaks. They are completely different approaches, and they are exploiting rules, they are truly groundbreaking, and they have the potential to change the world. So Julius, I'm going to get you to set the scene for us. And can you explain how sustainable aviation fuel, or SAF, is currently made? And then Peter, I'm going to pass to you to do the same for ammonia, talk about what it's used for and how it's currently being produced. And we'll take note about how particularly problematic that is.
So I should say something about how current fuel is made, because that sort of informs the way that's being done with SAF. So basically, you go around the world, look for somewhere to drill. You drill a hole, you take the crude oil out, you boil it, you get off the little stuff. You get the big stuff, you break it down. And at the end of that, you've got all kinds of different fuels. So you've got your diesel, you've got your aviation fuel. Now, in the case of SAF, they put different things into the front end. So there's sort of different recipes. And there's 7 different recipes that are recognized in the industry. Because you can't just put anything into an airplane, because airplanes tend to fall out of the sky if you don't put the right stuff in. So these different recipes involve corn, involve fats, so your chips, that sort of fat. Or it may be waste materials from a forest. Put them in, do various things to them, and the fuel comes out. And that's what you'll actually see on the slides. We're actually none of the above, because quite often when we came to talking to industry, they knew these 7 ways of doing things. So they were always looking for, so which one are you? Are you Fischer-Tropsch? Are you Fischer-Tropsch? So they're always looking for those sort of known solutions. In our case, it's a completely different solution. We take carbon dioxide, we produce fuel. And whereas in their cases, the current cases, you tend to take a material in and pull out the bits you want. It's a bit like, going back to a recipe, it's a bit like a cake. You pull the cherries out and the currants out. In our case, we start with the ingredients and we make the fuel. So that means that we can be very selective about what we produce. We can actually target different types of fuel, and we can target that list of fuel that I was talking about in diesel and what have you. So why SAF? Because it's one of the hardest things to solve, the hardest problem to solve. People will welcome that. And the reality is that SAF at the moment is very expensive. So it's up to 6 times as expensive as normal fuel. So if you're all running a business, you really don't want to pass that on to your customers if you can avoid it. So there's less than 1% being used at the moment. Similarly, there's a shortage of it because there's no money to actually put into it. And I came up with a statistic in 2030, there should be a shortage of this sustainable aviation fuel of about 26 billion litres. Now, that's a big number. So I try to work out, so how could that be, what's an analogy for that? So if you work out the weight of that and compare it to population, it's the population of the USA. So we'll be short of SAF by the population of the USA in terms of weight. Not that you should turn people, no, that's nothing to do with that. But just as an analogy. So the reason for those slides is that when we go in to talk to people, this is a brand new way of doing things. It's none of the above. Consequently, it actually takes a long time to explain to people, especially those who are knowledgeable in the subject, as to what it is that you're actually doing. And you have to spend a long time doing it. And in talking to Peter, he came out with exactly the same problem. So,
again, I think strategically you may have been put on a panel together for a reason. Peter, talk us through ammonia. Why are you not that?
Yeah, so very briefly, for those who might not know what ammonia is, well over 100 years ago now, we learned how to make ammonia in giant petrochemical plants, and it created a population boom because of the fact that it's used to make fertilizers. And if that discovery of how to make it in this giant petrochemical plant didn't happen, we'd have 5 billion fewer people on the planet now. So more than half of the population today is because of that one discovery of how to make this new process work. But as we tend to do, this was the process of, all right, we're going to throw fossil fuels at this problem and make it go away. It's one of the most polluting chemical processes on the planet, and it has huge contributions to global greenhouse gases, et cetera, et cetera. There's a lot of people now trying to come up with different ways to do it. The problem is we've become so good at making ammonia from fossil fuels and because of the fact it's used to make fertilizer and food, it's really hard to increase that cost because we need food to effectively remain the same price. And it's made it really hard for any kind of new clean technology options to decarbonize actually be accepted by customers. And so today, there's kind of two large-scale options. And large-scale is important because we need to have fertilizer en masse. We can't make small amounts of clean ammonia. We need it in really large capacity. And the two options are continue using fossil fuels and capture all of the carbon emissions. That's expensive. You basically add on a whole bunch of capital costs to your plant. The other option is to replace your fossil fuels with green hydrogen, which is taking water, putting it through an electrolyzer, huge amounts of electricity. Also really, really expensive. And both of those solutions are really hard to scale as well. We're kind of not quite there with them. But they're the two commonly accepted processes. And so when we kind of talk to customers about the fact that, hey, we actually discovered a completely new way to make ammonia, not with hydrogen and not with carbon capture. We're actually taking steam and air, they're our only ingredients, passing it through the reactor, and out comes ammonia. We're kind of met with comments of disbelief because this has been impossible before now. And the reason why we can do it is because we had a happy accident in the lab and discovered a new component that actually lets this fundamentally different chemical reaction proceed. And there's no other material that can do this. And so the thing that's been really interesting is that we have this advantage of, okay, cool, we have a new way of doing it. This has been seen a couple of times before. People using electrochemical methods, people using plasma methods. Our advantage is that we can do it at scale using existing infrastructure in what looks like the same kind of industrial scale plant that currently is used, but we don't need about 50 to 70% of that plant. We can get rid of all of those pieces of equipment. So it dramatically simplifies the process, CapEx comes down, our energy efficiencies are high, operating costs come down, and so what we end up having is a solution where we have a way to make clean ammonia, no emissions, at an overall cost that's comparable to fossil fuels or potentially even cheaper. And so this is the kind of really disruptive technology from our perspective that has, I guess, really large global customers and partners hooked that want to work with us.
So, Peter, you've touched on there that concept that people have tried stuff before, and this is in both your industries, and they have stumbled. And I feel that probably creates a challenge then when you're trying to then take this to market because you're straight up saying, oh, it's not that, but polished or wrapped in a green wrapper, and it's not this way. It is something completely new. And yeah, I know you got burnt that last time that someone didn't actually come through with the goods. So, Peter, I'll come back to you. What would be one misconception that you'd want to kill with this room today?
I think the misconception is that there's only effectively these 3 ways to make ammonia at scale. We've come up with a brand new solution. We're currently in a category of 1. We have no competitors in the class of ammonia production methods. We are the only other 3rd option. And that's something that's really hard to break down for these global players who say, okay, there's green ammonia and there's blue ammonia. Which one are you? We're neither. I don't want to call us a colour. People are trying to get away from that in the industry. But we represent this extra option. And when we start to talk to people, we have to do this unraveling of getting rid of preconceived notions of what we're doing before they go, oh, okay, this is something kind of really special. And we've found, I think, such good engagement from our partners because of the fact that, there are so few options to decarbonize a sector like this that any dramatic change like this poses a real threat to some of these companies. And so I think that's kind of where we're being perceived as.
Something you want to, a misconception you want to
so many misconceptions. We got to the point where on some of the slides we said that there's no magic involved and we don't create energy because people started thinking about that. For us, we try to reduce the risk and identify from somebody who's implementing it their perspective of how do you reduce the risk. So for us, quite often they say, oh, well, you're doing new stuff in here. We try to use all industrial, or it is all industrial scaled reactions that we use. We haven't got the benefit of an exotic catalyst that we can use, but I'll be coming to this guy afterwards. So we use standard catalysts. So we're trying to reduce the risk, and that sense it one. But as Peter said, I was in the UK listening to somebody, an airline talking on the stage, and they were saying, we've waited 4 years for our SAF, and we haven't seen any yet. And when we see it, we don't expect it to be very much. So all these other ones have come before us. So you have to overcome, first of all, the question marks in people's minds, but also the risk profile, and in some way motivate them to want to do this. And the 2 ways of motivating them is government and or money. So we started off with the money approach. If we can make this cheap enough and cost effective enough, then it'll be adopted. In Europe, they've actually also introduced government incentives. It's just come out, the refuel governance, which says that fuel producers have to produce a certain amount of CO2, produce a certain amount of SAF. If they don't do that, then they'll be fined. And they'll be fined against a reference price. So a reference price for normal fuel is about 730 euros per tonne. And they've put a reference price of 8,000. And you get charged twice the difference. And what's more is it gets carried forward. So there's a government incentives which certainly would incent companies to want to adopt the fuel. In Australia, we don't have that at the moment. So it's purely on the financial side that we're leaning.
So you've both touched on scale and solutions that, like you said, people waiting years for a product that still hasn't arrived and they don't even think it's going to be enough there. Peter, you talked about scale as well, and these solutions only sort of being viable if you can do it at scale. Can you talk me through what scale looks like in both of your companies?
So we had a conversation once with one of the world's largest marine bunkering companies, and what this means is they store marine fuel to fill up ships. It's fossil fuel based. They've understood that clean ammonia moving forward could be a replacement, a clean fuel alternative. And so we said to them, well, what's the smallest size of plant that we could build that would make you interested in offtake? And they said 1 million tonnes per year. And this is just an unfathomably large amount. And so they're only looking at plants which can build that sort of scale equipment. And the feedback we've been getting back from customers is effectively, look, for this to work, you need 3 things. You need, we keep on hammering it. The economics need to make sense. Someone needs to be able to afford to buy it in the end. You need to prove that it works, and we can do that through pilot demonstrations. And it needs to be a scalable solution. And we've heard that not just from one customer, but from multiple customers. Those are the 3 things that we need to hit.
Julius, what does scale look like?
Well, the scale for look for like for us. We did a sort of market research, as you do, and plants like this are about $1 billion plant. So that gives you a feel for how large these things are, where they have been implemented. Mind you, some of that, as I say, the cost driven in that is the materials they have to process. So the large plants. In our case, our anticipated first plant will be something equivalent to the demand from Qantas, say, for 3 times the demand of Qantas. So that's a reasonable scale. Interesting enough, we get questions of how big can you go, but also how small can you go? Because there are some constraints on some of the other solutions. Well, we can go as big or as small, but so what do you actually need? So we're planning to do the classic, put it in a container, move it around and replicate, so we can do that. For you, it starts at a higher level, because not every place has a lot of CO2. Some places have an awful lot of CO2, but other places, there's lots of different places which are producing CO2 that we could service, and we can make smaller.
Okay, you've got a captive audience. You can have a minute each. What's your ask?
Do you want to I'll start off the billion. Mine will.
I mean, look, we're at the stage in our journey where funding's hard. We're in a room full of people trying to do hard things with deep tech. The thing that we've kind of come across is it's hard to take investors. It's hard for investors, for partners, to take the risk on these early things, even if there's a really large promise of something that could be bright and shiny and world changing later on. And that's kind of where this, I think, funding gap lies. And so what we're at the process of doing is taking our technology, which we've reached proof of concept, scaling that up to understand the economics, and then we're going to be opening up a seed round later this year. That's going to be to develop our next scale of pilot demonstration, which will then act as our proof for our next scale up of pilot demonstration, which will then hopefully launch us into commercial projects. So if there's anyone that's looking at investing in this kind of clean energy space, please come and see me.
Okay, so just some money, right? Sweet. Julius?
Money? No. So as I say, you just can't put anything into a plane. You have to go to certification, and certification you need to produce enough fuel. So we're going through that, or we'll be going through that process starting in October for certify. But as I mentioned, this is a very flexible process, so we want to be able to also look at the other products that we can produce. So the intention is there's a go for the finish line on the certification, but also look at other products, as well as looking at the full scale plant to actually give some money back to the people who've given us money. So we're in the process of looking at, and we've had very good response in terms of the large amounts of money, but just like Peter, the little bit of money in between is the tricky bit. So we've got some for the certification, but we want to get on to the next stage, which is a lot less. It's hundreds of thousands rather than the hundred of million or millions that we need for the other one.
Okay, so I'm hearing little bits of money. I've already hit my husband up to remortgage our house to actually be some of that little money. But if you've got little bits of money or larger bits of money, then come and find these guys outside. Thank you very much.
Thank you.